So I think the matter always flow, right? So it's always liquid because you're working on liquid crystal. So it's a little bit liquidy on the stage as well. So it will be fine. Fluid. So I think I have been briefly introduce you all, but it would be much better to get to know all these distinguished guests by their own words. So I'd like to give a mic to you, giving like a couple minutes explaining about your journey to NASA and what is your role there. Please.
Who would you like to go first?
You can go first.
I'll go first. Thank you for having me. It's an honor to be here. Really a pleasure to meet everyone that we've met over the past couple of days and in working in this project for the past 6 months or so. My name's Scott Rodriguez. As mentioned, I'm Vice President of Government Programs for Voyager Space, also formerly NanoRacks. We've been purchased, which is why you hear both terms constantly. My voyage to space is a little bit different. I'm not one of those people, unlike some of the folks that you may talk to up here, that was fascinated by space growing up. I had a business degree and I went to law school, and then I got recruited out of law school by Lockheed Martin Space Operations to go work at NASA, and I was effectively just a glorified budget analyst, basically paperwork, that sort of thing. I left that for decades to go do some other things. But I married into NASA. My wife works at NASA, and I was kind of happily retired on my couch a few years ago, just quite pleased with my life. And a gentleman who started NanoRacks, Jeffrey Manberg, called and said, "Hey, would you come work with us?" Sounds like fun. Why not? Maybe my wife and I can have lunch in the cafeteria together at NASA sometime. So it was really that simple. That was about 4 years ago. Since then, though, I would say. What I do is, I think I have about 3 roles. I like to say about 20% of my role is business development, so sales. We're all, as Jeffrey Manber put it, when I first started, I was complaining about it. I was like, I don't want to be, I'm not sales, Jeff. I don't want to be business development. And he said, Scott, it's NanoRacks. We're all business development. But that's about 20%. About 20%, I manage a NASA program called Hunch, which is a STEM program, a workforce development program. And that's probably my favorite part of my job because we work with students, high school students in the U.S. primarily. And then about 60% of my job is, I would say, managing the relationships with our government customers and NASA, et cetera. So that takes a lot more effort than you would like. So like when I have to deal with this guy on stuff and try to figure out how we can get what we both need, that's about 60% of it. And that's the more challenging part, I would say.
Very fascinating. Like, it's a good example of someone not actually graduated in science and technology, but ended up working in NASA twice, not only once, right? So, all right. And married to someone in NASA?
Yeah.
That's even more fascinating.
It is. There's different NASA centers all over the United States. Johnson Space Center in Houston is the one where we all work, actually. And it's, I don't know, 10,000 people work there, something like that. But it's like a community. So my wife and I actually met playing sports at the Johnson Space Center athletic, complex 16, 18 years ago. And it's not uncommon to have that where we live.
All right. Thank you, Scott.
Well, I'm Robbie Hampton, Director of Operations for the ISS National Lab. I'm super excited to be here. It's great that we've got a big crowd. I hope we can inspire you today to become our future researchers in space or even future astronauts. My story is a little bit different than Scott's. I knew I wanted to work at NASA from a very early age. I was inspired by movies like The Right Stuff. That was all about the original astronauts for the Mercury and Gemini programs. I got to visit Space Center Houston and Johnson Space Center as a young boy and never looked back. So my whole life I kind of knew what I wanted to do, which was wonderful because I didn't have to think about it. My decisions were pretty much made. And I went to college at Embry-Riddle Aeronautical University, which had a very great aerospace engineering program, which we call rocket science, where I come from. It was very hard, very challenging, but I was lucky enough to meet some folks and get an internship at NASA working for one of the contractors. So I started working at NASA when I was 18 and worked 3 summers during college at NASA. And then when I graduated, I went to work full-time for a company called Ares Corporation. We did systems engineering on the space station, so that was my job during construction when we were bringing up all the new modules with the space shuttle. And then after the construction was complete, I found a job at CASIS, the Center for the Advancement of Science and Space, managing the ISS National Laboratory. So I went from a company that helped build the space station to one that was now going to utilize it. And our mission was to open up access to the space station for all non-NASA users. So folks that weren't associated with NASA and wanted to do research in space or advance their technology. And it's been a privilege and an honor to be able to do that for the last 12 years. I get to work with great companies and great folks like Scott and Mike and meet wonderful aspiring professors like Nataporn and come to places like this and learn about what you're doing and all the great things that you want to do in the future, and hopefully we can help you get there.
So thank you so much. It's good and inspiring message that you inspired by a movie and ended up pursuing your dreams and become one today. So congratulations, and hopefully it's inspired all the audience over here as well. Over to you.
And I recommend watching that movie. It's very, very good. Thank you guys so much for having us today. It is a pleasure and an honor. Thank you for the warm welcome, and thank you to Dr. Nataporn Chatham for introducing us to the amazing science that's being done here. My name is Michael Lewis. I'm the Chief Technology Officer of NanoRacks Voyager. We're a private company, and we are responsible for putting a lot of fun things in space. My journey was similar to these. I went to school for rocket science, and early on, I was privileged and I got to fly an experiment. I flew a mouse experiment on the space shuttle. My job was to clean the rat cages on the ground. It was not very glamorous, but I learned a lot about space, and since then, we've been able to fly a lot of experiments. I've been a part of NanoRacks since 2011, so for 13 years, and I've been a part of over 1,000 spaceflight experiments. It's been very fun. And I think what we'll show you today is that there's a lot of science, education, research to be done in space, and it's not just for rocket scientists. Everybody benefits from the stuff that's happening in space, and everybody can work in space. So based on the work that's happening here, we think Thailand is a leader in this area, and we think that we're going to see a lot more research come out of here. So very exciting. Thank you.
All right, thank you. So another exciting story inspired by the same movie somehow, and become like one of the leader in the team as well. So maybe our distinguished guests in Thailand might not be inspired by the same movie, but happen to work on the same project. So over to you.
Okay, my turn. Well, thank you. Well, thank you. Thank you all for joining us today, and thank you our guests for flying over to Thailand. So my journey is starting as a physics student here at Kasetsat University, bachelor degree. I graduated here, and I also have my supervisor here, Ajahn Siwapon Sahawat, from my undergraduate watching me. So she's in blue. Well, thank you for guiding me to the journey that's end up to be something amazing. So since I graduated from physics department, I start my school at University of Colorado in Boulder, same one as you, but different department.
Yeah,
so I was
Go Bucks. Yeah.
yes, I was in physics, and there I studied liquid crystal. I was like a physicist, like spending time in my lab, and suddenly my advisor got funding from NASA. So that's the starting journey. So I was still in the lab, and then I was doing all the work with NASA supervisor visit from time to time with my colleague here, Dr. Abhishek, which is we were at the same lab at the University of Colorado, and I've seen him for like 20 years. We're still working together. So from there, my supervisor, my advisor at that time, he aimed to go to space. So he's going for the ISS since we start school back in 2000. And then we get to space. He got to space in 2015. 15 years of hard work, up and down, up and down. So that's the journey we are facing. So then I'm still like a physicist. I wasn't that inspired to go to space yet because I don't know if I come back to Thailand, what am I going to do? I will be like liquid crystal scientist, but no space as an extension yet until I start as a professor here. And then I was getting my Alexander von Humboldt fellowship to go for the postdoc in Germany. Then I go back to work on the same project. It's a NASA project called OASIS, but in collaboration with DLR, like German Aerospace Agency. Over there, what they do to me, they put me on the zero gravity flight. They were like, you hop on, no training. I look like disaster. It was like floating. At the first time I hit the ceiling. Yeah, and then yeah, the ceiling of the plane under zero gravity. So I told myself, okay, well, if I have my project in space, I'm going to do better in space. I'm going to have a nice picture because my picture in there is like, you won't believe it. Then I come back, continue my liquid crystal research. I'm still keep contacting with my supervisor from USA, my supervisor from Germany. So everyone involved in the space project. Then 2018, suddenly the click come in. They put everyone together. Then I hop in as the representative of Thailand to join the project. And that's the originate of Thailand liquid crystal in space.
Thank you so much. Also, another fascinating story about how Thai girls, right, raising up like being physicists, aim for being physicists, and ended up having some application that can be used in space. And I think we have learned a little bit from all this speaker, and as I promised, I might switch into Thai a little bit to do a little bit capture. จากที่เราได้พูดคุยกับวิทยากรเกี่ยวกับประวัติความเป็นมาแต่ละท่านที่ทำยังไงถึงเริ่มมาทำงานกับ NASA ได้นะคะจะเห็นได้ว่าแต่ละท่านเนี่ยมีแบ็กกราวด์ที่แตกต่างหลากหลายไม่จำเป็นว่าจะต้องเรียนจบวิทยาศาสตร์และเทคโนโลยีเสมอไปและทำงานกับ NASA นะคะเราก็จะมีบางท่านที่จบสายการเงินการบัญชีเนาะทำงานเกี่ยวกับ business เป็นหลักไม่คิดเลยว่าวันหนึ่งจะมีโอกาสได้มาทำงานกับ NASA แล้วก็สุดท้ายก็คือนอกจากทำงานกับ NASA แล้วมาแต่งงานกับนักวิทยาศาสตร์ NASA อีกนะคะอันนี้ก็เขาเรียกว่าบุพเพสันนิวาสนะคะทำงานใน NASA 2 รอบแรกทำแล้วสักพักก็ออกไปทำงานกับบริษัทเอกชนแล้วก็กลับมาทำงานกับ NASA อีกนะคะท่านแรกท่านที่2เนี่ยกับท่านที่3เนี่ยเป็นวิศวกรนะคะที่เรียนมาด้านเกี่ยวกับ Space มาโดยเฉพาะเลยแล้วก็มีความฝันอยากจะเป็นนักวิจัยอยากจะเป็นวิศวกรที่ทำงานด้านอวกาศนะคะจากการดูภาพยนตร์นะคะซึ่งเดี๋ยวเขาจะแนะนำให้เราไปดูบ้างค่ะเพื่อเราจะมีอินสปิเรชันมาเป็นนักวิจัย NASA แบบทั้งสองท่านส่วนอาจารย์เอของเรานะคะใฝ่ฝันอยากเป็นนักฟิสิกส์นะคะไม่ได้เคยคิดมาก่อนเลยว่าวันหนึ่งจะไปทำงานกับ NASA แต่โชคชะตาพาไปใช่ไหมคะอาจารย์เอใช่ค่ะอาจารย์เอลองเล่าให้น้องๆฟังโชคชะตาพาไปแบบภาษาไทยก็ได้ค่ะว่า
ก็โชคชะตาพาไปเพราะว่าตอนแรกที่อาจารย์เอเนี่ยทำงานทางด้าน Liquid Crystal ที่อเมริกาเนี่ยก็ Advisor บังเอิญว่าเป็น Top of the World ทางด้าน Liquid Crystal ก็เลยได้มีโปรเจกต์กับ NASA คราวนี้อาจารย์ก็จะต้องขึ้น Space คราวนี้มันใช้เวลาในการขึ้น Space นานมากเรียนจบมาแล้วอาจารย์ก็ยังไม่ขึ้น Space เลยเราก็เลยไปเป็น Postdoc ต่อที่เยอรมันคราวนี้ตอนไปเยอรมันเนี่ยเขาไม่พูดพร่ำทำเพลงอะไรแบบอยู่กระโดดขึ้นไฟล์เที่ยวบิน 0G ไฟล์ขึ้นไปบิน4 ชั่วโมงคือนึกออกไหมแบบไม่มี gravity แล้วข้างในมันจะอยู่ตรงเนี้ย คือทรมานมากมันคือความทรมานที่สุดในชีวิตแล้วก็ถ่ายรูปออกมาได้คือต้องบอกว่ามันไม่สวยเลย ก็เลยมีเป็นแรงบันดาลใจว่าวันหนึ่งเราจะทำ Space Project ของตัวเองเราจะถ่ายรูปที่ดีกว่านี้มาอวดทุกคน
วันนี้เลยสวยมากนะคะ วันนี้สวยไหมคะจันเอ๋สวยไหมคะสวยเนาะโอเคก็โอเค so I think we already captured the inspiration of everyone becoming one of the NASA missions, right? So now I'd like to dig a little bit deeper about your missions in NASA. So I'll first start with you, Rob. So maybe could you please explain a little bit about space research on International Space Station? What kind of research are conducting there, and like are there any particular research project that you find fascinating?
Yes. At the ISS National Lab, we have a few missions. One of them is to continue to develop our basic understanding of fundamental science. So we look at all the physical processes. When you take gravity away, it changes almost every process that we know and are familiar with. So we do basic physics research, fluids research. We're looking at material science, biology, cellular biology. How do your cells adapt in space? We're looking at the Earth from space. You know, the space station is a wonderful platform filled with many facilities to support all this research. And then once we gain a basic understanding of the underlying principles that create all this phenomenon, we then try to apply that through more applied research. So taking what we've learned and using it for an application to benefit those of us on the ground, whether it's developing new pharmaceuticals or printing a new organ, perhaps creating new materials for your liquid crystal displays, or your cars, or your airplanes, new semiconductors that go into your computers. Understanding your crop health, how well your crops are growing, and if they need to be watered or too much water. We do all of these things from the space station, and then we also help try to develop an economy so that the future space stations will be able to survive without as much government support. So we work very closely with many companies like NanoRacks and Voyager to help them grow as a business and become the suppliers that help researchers do research and other fun and awesome things in space.
I believe you also have some video to show about your research, right?
We have our video. It's like a commercial for what we do.
Maybe you'll look at the video to get inspired a little bit more.
It is very much go time here. We have been working long days. Every time a mission launches and we have experiments on it, you just get a sense of pride, but I also get a sense of anxiety because that's really where the rubber meets the road. All of the work that we've done for the last year and a half comes to fruition and hopefully results in a successful experiment on board station.
In the 22 plus years of continuous human presence in space, we have successfully demonstrated the ability to live and work in space.
The NASA team and our team work hand in glove. There's not a problem that we can't find a way to solve.
NASA and the National Lab have a phenomenal collaboration that has really resulted in high throughput science.
For the first time in the history of human spaceflight, we're actually going there in order to do things that have direct benefit on Earth.
The research our partners are doing on station is aimed squarely at solving some of humanity's biggest challenges: curing cancer, curing heart disease, reversing climate change, improving the performance of semiconductors, solving the shortage of human organs by manufacturing artificial organs in space.
So on this mission, we actually have two projects. And they're both looking at engineered heart tissue, but we've also supported lung tissue experiments, biofilm experiments.
Right now, we're printing simple tissues, but the holy grail is the ability to assemble an entire human organ in space.
I am really excited to see some of the breakthrough science that is happening on station in the microgravity environment that as a scientist, I know I could not deliver on Earth.
Let's get up there, let's do the work in space, bring it back, and do something that really has a chance of changing humanity.
We are absolutely just scratching the surface of what's possible in low Earth orbit, what's possible in space.
I think through the ISS National Lab, we are really expanding the options for all researchers on the planet to do cutting-edge research in space.
You realize how much researchers and companies don't even know that they can leverage the ISS.
We're in this unique position to talk to all kinds of businesses and industries about the challenges they face in their everyday tasks.
I think it's to National Lab's credit that they have given the opportunities for payload developers like us to prove that these things are not only tenable in space, but economically feasible as well.
Building that type of ecosystem in low Earth orbit is going to require the participation of many government agencies, many nations, and most importantly, many different industries.
It takes a lot of skin in the game from everybody to put their heart and soul and their ideas on the table and to have the bravery to test them out.
We supported a project that looked at treating kidney disease, and my engineer who was designing the hardware kept saying, we're working on curing kidney disease. And so that makes us very proud, makes us feel like we're creating a difference in people's lives.
That's really the essence of what we do, is we connect our resources with people who are looking for them, and we try to create the best environment for them to be successful.
The rocket launches are amazing. When you see the fire light up underneath the vehicle,
You can feel your heart coming out of your chest because it's so exciting and everyone is feeling like this mini sigh of relief. But as soon as it's done, we can't wait to get back to the lab and finish the work.
It takes a village, but that village is coming together and the results are going to be magnificent, and we're all going to see it in our lifetime.
ก็อย่างเมื่อกี้ที่ขอให้คุณโรเบิร์ตช่วยเล่าให้ฟังว่ามีงานวิจัยอะไรที่น่าสนใจเกี่ยวกับของทางISS บ้างนะคะก็จะเห็นได้ว่าเขาก็พยายามทดลองว่าถ้าไม่มีแรงดึงดูดของโลกแล้วเนี่ยการเกิดของสิ่งต่างๆเนี่ยจะเปลี่ยนแปลงไปยังไงแล้วงานวิจัยต่างๆเนี่ยก็สามารถเอากลับมาใช้เป็นประโยชน์ต่อโลกมนุษย์ได้ด้วยจะเห็นได้ว่ามีงานวิจัยหลายอันนะคะที่เกี่ยวกับเรื่องของการพัฒนาชิ้นส่วนอวัยวะของมนุษย์นะคะการทำงานของพืชนะคะว่าจะมีการเจริญเติบโตเปลี่ยนแปลงไปอย่างไรในสภาวะที่ไร้ซึ่งแรงโน้มถ่วงของโลกนะคะซึ่งต่างๆเหล่านี้ก็เป็นโอกาสที่จะเอากลับมาใช้ในชีวิตประจำวันทำให้คุณภาพชีวิตของเราดีขึ้นนะคะนอกเหนือจากนี้เนี่ยสิ่งที่นักวิจัยเขาทำงานแล้วเนี่ยเขาก็มุ่งหวังว่าทำยังไงที่การลงทุนในงานวิจัยเนี่ยจะไม่จำกัดอยู่แต่การใช้เงินของภาครัฐทำยังไงให้เขาสามารถสร้างรายได้จากการทำงานวิจัยในอวกาศก็มาลิงก์กับเรื่องของ Space Economy ที่เราพูดกันวันนี้นะคะว่าทำยังไงที่เขาจะสามารถ generate income นะคะสามารถทำให้ NASA ไม่ต้องถูก subsidize โดยภาครัฐอีกต่อไปซึ่งตรงนี้นะคะก็เป็นที่มาของมิชชั่นต่างๆที่เขาพยายามทำนะคะมันก็เลยมาลิงก์ว่าทำไมจะต้องมี business development so I linked it back to you because he mentioned about economy space economy and you are the only one here as a business developer
well Mike is too but
oh
we're both
not only both of you
like I said it goes
both
back
of
to
you
we're all business development in Antarctica
right so it needs both of you to develop the business
yes
but to develop the business you also need to develop the future generations so I heard about some fascinating program that you have Nano Hunch program which aim to empower and inspire the next generation people here may be included in the future not now but in the future so could you please elaborate a little bit about your program goal and NASA motivation behind it an opportunity for the international participants.
Of course. So HUNCH, my favorite thing to talk about that I do, it stands for High School Students United with NASA to Create Hardware. Not the best acronym, but it's what we've got. We didn't start it. NASA started this about 20 years ago. The ISS program started it. They were looking at some hardware they needed built, like training hardware, and somebody came up with the idea of, well, what if we got high school students to build it? And it started out, the idea was it's training hardware, like ground hardware. It's not that important. Anyone can do it. Okay, fine. But the students far exceeded everybody's expectations, working with local high schools originally, I believe. And the hardware they built was so good with the help of the HUNCH program mentors that it's developed into building flight hardware for the ISS and for NASA now going on 20 years. I think HUNCH has flown over 2,000 items to the International Space Station. It's the program as we have it now, and NanoRacks manages the HUNCH program for NASA now, is why I'm the program manager. We have 8 different disciplines, and I'll zip through them. I know we're running a little long on our answers, but we do hardware, which is basically we build flight hardware. Imagine lockers, handrails, things that the International Space Station requires. We have students around the country in the United States, where I think we're in about 40 different states and over 200 high schools. They actually build in their local machine shops in their schools pieces of the hardware. We assemble them in Houston, where we are, and we deliver them to NASA for flight. The list is extremely long on the number of things they make. We also do sewn flight articles or soft goods, so industrial sewing. There's a lot of industrial sewing requirements for the International Space Station for space travel, everything from cargo bags to sleeping bags to socks, you name it. And the HUNCH program develops and delivers a lot of those products. We also do something which is called design and prototype, and this is the one that I find to be most fascinating. Basically, NASA or the crew office will come to us with a problem. They'll say, we don't know what to do with our tape on orbit, like rolls of tape. What we do is we hand that problem to students at the beginning of the school year all over the country, and we let teams from different high schools sort of work on and develop solutions to it. We help them, we mentor them as they go. We have design reviews so that we can give them feedback, and we actually end up with a final design review at some point, and those items end up being part of the ISS. Like the HUNCH tape dispenser is on orbit now, and it is where NASA astronauts dispense tape from. That's just one example. We've done a ton of things through the design and prototyping challenge for NASA and just solving problems they have. Flight configuration is another part, and this is where we take those, like the tape dispenser, and we turn it into flight hardware. That's not as much student involvement, but they do the drawings, they learn CAD, they learn AutoCAD, they learn how to do the quality control checkouts and things like that. We also do I know you might be interested in this, we have a culinary challenge. We should change the name to food science, but what we do is we have teams, again, from all over the country. We give them a dish for that year, or not a dish, but a theme for that year. And we ask them to design a dish for space along that theme. We have preliminary, I guess they're almost like cooking competitions, and we invite the top 10 from now around the world. We open this up to international participation. The top 10 schools from around the world come to Houston. We just did it a couple weeks ago, and prepare their dishes in what is effectively like a cooking competition. The winning dish, and there's a lot more to it, it's food science, right? So there's a lot of things that go into diet for astronauts, low sodium, etc. There's taste issues, in orbit when you're in zero gravity, your food might not have this problem, but in the United States, they don't taste as much. So they want more spice because it doesn't flow over the taste buds like it would.
Maybe Thai food then.
Thai food would be perfect, exactly. I can vouch for that. No astronaut complaints for that. But the winning dish actually becomes part of the crew's on-orbit menu that they fly. And we also provide scholarships to culinary schools for the winners and things like that. We have a few other programs, software. We do biomedical research now, so it's like design and prototype, but we were getting so many requests that were biomedical in nature, biomedical science, that we just created a whole spin-off group of that. And we do a video and media challenge. But it's been phenomenally successful, funded by the ISS program entirely up to this point. We now, since NanoRacks has taken it over at the request of NASA in expanding it, because the ISS has a shelf life, right? At some point it's going to end. So we have to look for a new home for HUNCH, probably within NASA with the exploration programs like Moon to Mars, but also commercially, commercial space stations like the one we're potentially building. And we've established an international component to it. We got permission from NASA to expand Hunch to international locations. We can't fund it, so it's got to come with its own internal funding, but they can be part of the Hunch program. We can still mentor them. We can still help them develop their programs. We started a pilot program in Norway. That's the first one we chose. I'm going to be over there next month. They've already kicked it off. They're doing phenomenally well, and there's no reason why you couldn't have a program in Thailand participating in NASA Hunch going forward.
Okay, so I don't call it as a promise, but it's a potential. So I'll do a little bit recap here. So สำหรับคุณสกอตนะคะที่บอกว่าเขามีโปรแกรมที่ส่งเสริมเด็กและเยาวชนเนาะให้มีโอกาสได้เข้ามาร่วมเรียนรู้แล้วก็สร้างประสบการณ์กับทาง NASA นะคะเขามีโปรแกรมที่ชื่อ Hunch โปรแกรมซึ่งให้นักศึกษาเรียกว่านักเรียนดีกว่านะคะนักเรียนมัธยมเนี่ยทั่วอเมริกาเลยมีโอกาสในการร่วมพัฒนาฮาร์ดแวร์ที่เอามาใช้กับ Space Station นะคะซึ่งเขาก็มีโจทย์ต่างๆแล้วเขาบอกว่าตลอดระยะเวลากว่า20 ปีเนาะที่เขามีโปรแกรมนี้มาเขาบอกเขาไม่ได้เป็นคนเริ่มโปรแกรมนะแต่เขามาเป็นแมเนเจอร์ของโปรแกรมนะตอนนี้เนี่ยแต่ว่าเขาก็มีโอกาสได้เห็นโอกาสที่เป็นโปรแกรมที่เขาชอบมากเพราะเห็นโอกาสของการส่งเสริมให้เด็กและเยาวชนเนี่ยมีความคิดสร้างสรรค์คนนาซาคิดว่ามันมีของหลายอย่างเลยที่ต้องใช้ในอวกาศทำไมไม่ลองโยนเป็นโจทย์ให้เด็กๆไปลองฝึกคิดฝึกทำแล้วก็ทำในโรงเรียนมาประกวดแข่งขันกันแล้วเขาก็มีโอกาสได้นำของเหล่านั้นน่ะออกไปในอวกาศจริงๆนะคะมีหลากหลายโปรเจกต์แล้วก็หลากหลายลักษณะของโปรเจกต์แล้วเขาก็มีเรื่องของการทำ prototype development ถ้าน้องๆเคยเรียนเรื่องของ design thinking เนาะคอนเซปต์เดียวกันเลย ideate and prototyping เนาะแล้วก็เอาไปทดสอบจริง rapid prototyping เอาไปทดสอบจริงเขาก็ไปทดสอบจริงในอวกาศนะคะแล้วก็มีกว่า 20,000 ชิ้นนะคะที่ถูกพัฒนาแล้วก็มาใช้นะคะอันนี้ก็เป็นโอกาสแล้วเขาก็บอกว่านอกจากโปรแกรมนี้ตอนนี้มันถูกจำกัดอยู่ในอเมริกาก็จริงแต่ว่าเขาก็เริ่มที่จะเปิดขยายโอกาสนะคะให้เอาโปรแกรมแล้วก็เอาคนของเขาเนี่ยมาช่วยเป็นเมนทอร์ให้แต่อาจจะไม่ได้มีเงินทุนอะไรประเทศก็อาจจะต้องสนับสนุนเองซึ่งประเทศนอร์เวย์เนี่ยก็เป็นหนึ่งในประเทศที่รับโครงการนี้ไปอาทิตย์หน้าเขาจะบินไปนอร์เวย์นะคะก็หวังว่าเราจะมีโปรแกรมแบบนี้ในเมืองไทยน้องๆจะได้มีโอกาสได้ทำงานกับนักวิจัยนาซาบ้างนะคะโอเค so
I couldn't have said it better myself. You nailed it.
I mentioned that you would love to work with Thai students on your project at some point.
We would love to. We'd like to see Hunch global. I think it's a good program for workforce development. It's a good program to get people thinking about space. As we move forward in the space economy, it's not going to be just engineers. And we have engineers in the Hunch program and the design and prototype that come through there, but you're going to need machinists, you're going to need industrial sewing, you're going to need different culinary, all kinds of things as we go into long duration space travel. So it's a great program. I'd love to see Thailand involved. That would be fantastic. Plus I love coming here. So
that's great.
That's another good bonus.
แล้วก็อันนึงที่เขาบอกนะคะว่านอกจากเราพูดถึงเรื่องฮาร์ดแวร์ไปแล้วเนี่ยมันมีเรื่องอื่นๆอีกเช่นเรื่องอาหารการกินเนาะไปอยู่ในอวกาศเนี่ยทานอะไรดีอะทานอาหารแคปซูลก็คงน่าเบื่อแย่เขาก็เลยบอกเขาก็มีปัญหาเนาะว่าแค่เราขึ้นเครื่องบินอาหารบนเครื่องบินยังไม่เหมือนบนทานที่บ้านเลยนะรสชาติมันต้องจัดจ้านกว่าอาจารย์ก็เลยเสนอไปว่าทานอาหารไทยไหมเขาบอกเขาสนใจเนาะเพราะฉะนั้นก็มีโอกาสเหมือนกันว่าจะ develop อาหารไทยไปอวกาศกับเขาบ้างนะคะ so I think I'll over to you for the next questions so we learn about space economy and you having lead the NanoRack so maybe we would like to know a little bit about the activity at NanoRack anything exciting about it
Absolutely. So we live in a really exciting time for space. A lot of people don't know, but the space station has had people in it for over 20 years. So many of you in this room, your entire life, there's been people in space. And those people are doing really exciting things, and we get to be a part of that. They're doing research. They're learning about the human body, the things that happen to your body when you go to space. You lose bone, you lose muscle. We need to figure that out because that can help everybody on the planet. We study a lot of the things that Robbie was talking about, materials and plants and agriculture. We learn how plants work so we can make better crops on Earth. And at NanoRack, we get to be a part of that. One of the fun parts about NASA and the space station is that back about 20 years ago, when they were building the space station, they were almost done. And they said, uh-oh, what do we do now? and as it turns out, they wanted to use it for a laboratory. And that's why the ISS National Laboratory exists. These guys allow us access to use this as a lab, like you would in a university. And we were the first to sign up, and we've been the biggest user of that. So I get to see a lot of really cool science. And we started with small science. The company was called NanoRax, and nano means small. And we've started getting bigger and bigger. We've put a lot of satellites into space, and then we built a part of the space station. I'm very fortunate. I'm listed as one of the inventors of the Bishop airlock, which is part of the space station. But all this led to more. And I think we have a video that'll explain this. But we kept building things that got bigger and bigger and bigger, and we recently got an award from NASA to look at building a new space station, a private commercial space station. So I have a video to show.
Hey guys, welcome back to Test Spaceflight. Today, we've got some groundbreaking news that's sure to set your space-loving hearts racing. Brace yourselves as we dive into the details of the game-changing Starlab and its historic partnership with SpaceX. Starlab, a joint venture between Voyager Space and Airbus, is set to be a cutting-edge commercial space station, aiming to revolutionize space research, tourism, and beyond. And now, the big news, it's taking a historic ride on SpaceX's Starship rocket. But, why is this such a big deal? Starship is SpaceX's next-generation rocket, capable of carrying heavy payloads and setting new standards for space travel. Starlab's developers have chosen this behemoth for its journey into orbit, making it one of the earliest commercial customers for this colossal rocket. So, when can you expect this historic launch? Hold on to your space helmets, because Starlab is aiming for liftoff as early as 2028. It's not just a launch, it's a seamless transition from the International Space Station, which is set to retire around 2030. The single launch solution with Starship eliminates the need for risky on-orbit assembly and multiple launches. But wait, there's more. Starlab has an unexpected ally. Hilton. The iconic hotel chain is teaming up with Voyager to bring its hospitality expertise to space. Imagine reimagined cruise suites and an unmatched space experience. Starlab isn't just about the excitement of space travel, it's a game changer for research and sustainability. With Airbus providing technical design support, it's set to become a microgravity research hub and a home for the George Washington Carver Science Park. The collaboration is groundbreaking and is shaping the future of space exploration and scientific advancements. And let's not forget its potential impact on future hotel designs, both in space and on our home planet. So, there you have it folks, the latest and greatest updates on Starlab's journey into space. From the choice of Starship as its launch vehicle, to the unexpected partnership with Hilton, the excitement is building up. Make sure to stay tuned for more updates, as we witness the future of commercial space exploration unfold before our eyes. Don't forget to hit that subscribe button, give this video a thumbs up, and share this mind-blowing news with your fellow space enthusiasts. Until next time, keep looking up, because the universe is full of surprises.
So, as you can tell, that was AI made, which I'm pretty happy. Scott's over here squirming, going, what is this? As you can see, the future is really exciting. We're building a space station. We're putting it on a SpaceX rocket. And we just bought the rocket recently. And you know what they give you when you buy a rocket? Zero. Nothing. We hope for t-shirts. We wanted stickers. We bought a rocket and we got nothing. From SpaceX. From SpaceX. Yeah.
You got space anyway.
Yeah, exactly. So you asked, what are we doing? What's exciting? And I said the time we live right now is very exciting for space. This is what's going to happen in the next couple years. We're going to have private space stations. We're going to have multiple private stations that are up there that can be used for not only science and research, but mass production of liquid crystals and pharmaceuticals and materials and semiconductors and all these amazing things. So, thank you.
Thank you so much. So Mike ก็เล่าให้เราฟังนะคะว่างานที่ NanoRack เนี่ย มันน่าสนใจมากเพราะว่าเขาก็พยายามที่จะนำในส่วนของการลงทุนภาคเอกชนเนาะเอามาร่วมกับการทำงานในเรื่องของอวกาศนะคะซึ่งจะเห็นได้ว่าสิ่งที่เขาบอกก็คือว่าอนาคตอันใกล้เนาะสถานีอวกาศนานาชาติเนี่ยจะปลดระวาง 2020 นะคะซึ่งก็เลยมีความจำเป็นที่จะต้องมีSpace Station อันใหม่แล้วก็อันนี้เป็นการเริ่มต้นของการที่จะมีสถานีอวกาศของหน่วยงานเอกชนนะคะซึ่งจะเห็นได้ว่าการร่วมมือเขาก็ไม่ธรรมดานะคะร่วมมือกับเครือโรงแรมฮิลตันเนาะเขาก็กะจะทำสถานีอวกาศที่ประกอบการให้สามารถเข้าไปเยี่ยมชมอวกาศได้ในอนาคตนะคะซึ่งเขาก็จะเริ่มลอนช์อีกไม่นานนะคะดังนั้นเนี่ยก็จะเห็นว่าช่วงนี้เป็นช่วงเวลาที่น่าตื่นเต้นของเรื่องของอวกาศแล้วก็โดยเฉพาะยิ่งเรื่องของเศรษฐกิจอวกาศนะคะทีนี้เดี๋ยวจะขอกลับมาให้นักวิจัยฝั่งไทยนะคะ so back to you อาจารย์เอ๋ so we have heard a lot about the space and now we would like to learn a little bit about how like Thai's research collaborating with NASA and could you please explain a little bit about your contribution on research to NASA because he already mentioned that maybe mass production of liquid crystal under his station. Yeah.
Yes, well, thank you. So my contribution to NASA is, for example, the space helmet. So in the future, yeah, the space helmet will be, inserted with liquid crystal display. That's what we hope for. I've been to the biosurf space in Colorado. I saw the camera in front of the astronaut suit. It looks terrible. Amazingly, like all the pixels are gone. It's only like you can roughly see like the broken TV. So that's how the electronic in space will be disturbed. So in the future, with all the technology, with all the research that we are part of it, we'll hopefully that we can build something better. We can, have the TV in the Hilton, in your room on the space station, like with a bright screen. That's the future. So we're looking forward to that contribution. So as of now, that the Thai researcher get from what we're doing is the knowledge. Because currently our country, we are baby in the space technology. So what you guys come here is to help us learn, like the system engineer to integrate with science concept that we have. Our students, they all learn so much. They learn like, you can't use this pipe in space. It's not allowed. They're like, when they hear ethanol, they're like jumpy. You're not allowed in ethanol on the ISS. Why? Why no ethanol on the ISS?
I think it's
Well, Scott said that is the flammation on the ISS okay?
Flammability.
Yeah, it's flammability.
It's not that
Is
big.
it okay? It's
Fire's not that big a deal. It's like, does this work?
So yeah, they teach us a lot for what's allowed and what's not allowed because you have astronaut in space. When it's flame, what would you do? You would be like Apollo 13, if anyone watch it. So that was, you have to be very careful when there's someone up there in space. So that's what we learned. The bolt, not, it has to be tightened. When you unscrew it, it will jump to your eye. So that's a minor little thing. Every little piece of thing you have to be, you have to take care of it. So our students learn, not only science, but all the delicate engineering. That's what we got from this project. So we have, if I may show the team picture. So our team, that's when we were at Thailand Space Week. So we are a huge team. And this is the student, undergraduate, graduate, postdoc, engineer. So this team work together every day. Not only every day, every night. Why? Because NanoRack in the USA, They
We are only like 12 or 13
we only
hours
12 hours different. So they train us at like 9 p.m. until midnight. So it's not that bad. And the next day, we have to meet our consultant from University of Colorado, 7 a.m. So not that bad neither. So this team get used to adjust their time to get along with the whole world. So this is another thing they train. So it's like a lot of valuable thing that you learn to work internationally with the partner around the world. So this is what we get, and we really appreciate all this knowledge that we learn. So we would be like not only the science project, it will be like a diplomatic project as well. So that's the valuable of what all of our team get, and what the student and the university and all our professor in the team, and also we have a big team also related to other university as well that give us related research to support the main research. So this is what we earn. Yes, thank you.
Thank you so much. ก็ขอบคุณอาจารย์เอนะคะอาจารย์เอก็เล่าให้ฟังว่านอกจากที่ทีมของอาจารย์เอเนี่ยเริ่มทำงานมีโอกาสได้เรียนรู้จากนักวิจัยจากนาซาเนี่ยนอกจากจะเรื่องเทคนิคแล้วเนี่ยยังมีเรื่องเล็กๆน้อยๆที่เราอาจจะคาดไม่ถึงเนาะจากการทำงานร่วมกับนักวิจัยในต่างประเทศที่มีประสบการณ์ในอวกาศนะคะนอกจากนั้นเนี่ยก็จะเห็นได้ว่าการทำงานร่วมกับต่างประเทศก็มาพร้อมกับความเสียสละอันยิ่งใหญ่ใช่ไหมคะที่จะต้องทำงานต้องบอกข้ามเวลา นะคะเพราะว่าระยะเวลาที่ไทม์โซนที่แตกต่างกันเนาะ12 ชั่วโมงก็ทำให้อันนี้ต้องบอกว่าเรียกว่าวินัยนะคะส่วนหนึ่งของการทำงานแบบมืออาชีพก็คือวินัยในการทำงานมุ่งเน้นเรื่องผลลัพธ์ของงานนะคะโดยที่ไม่ย่อท้อแล้วก็จะเห็นได้ว่าอาจารย์ก็สร้างทีมที่ไม่ใช่เฉพาะนักศึกษาในมหาวิทยาลัยที่มีโอกาสได้เรียนรู้ postdoc นะคะคนทำวิจัยก็เป็นทีมใหญ่ที่มีโอกาสได้เรียนรู้ไปพร้อมๆกันนะคะก็หวังว่าวันหลังน้องๆที่นั่งอยู่แถวนี้จะเข้ามาอยู่เป็นส่วนหนึ่งของแลบอาจารย์เอนะคะแล้วก็อาจารย์เอก็บอกว่านอกจากเรื่องของการทำงานวิจัยเพื่อความก้าวหน้าของงานวิจัยแล้วเนี่ยเดี๋ยวนี้มันก็มีคอนเซปต์อีกอันหนึ่งเรียกว่า science diplomacy เนาะความสัมพันธ์ระหว่างประเทศเนี่ยนอกจากจะใช้จัดเจรจาทางการทูตแล้วเนี่ยส่วนสำคัญอันหนึ่งก็คือการเจรจาความร่วมมือทางงานวิจัยด้านวิทยาศาสตร์เพราะฉะนั้นคนทำงานด้านการทูตเนี่ยนอกเหนือจากจะมีความเชี่ยวชาญด้านรัฐศาสตร์นะคะอาจจะต้องมีเรื่องของวิทยาศาสตร์ติดปลายนวมสักนิดหนึ่งเพื่อใช้สำหรับการเจรจาระหว่างประเทศนะคะ So I think we got everybody excited about how fascinating all your works are. So maybe we would like to learn a little bit about the opportunities or what's out there for these young generations. So maybe I'll start with you, Scott, on like from your perspective of what are the opportunity for young people involving in the space project today.
I want to. It's a great question. I want to touch on a couple things. Number one, well, first of all, Nanaporn asked about or mentioned fire on the space station. I think actually one of the creators of the fine water mist fire extinguisher is in our audience today, which is how you would combat a fire. I always thought you just hit a red button like you see in the movies and all the air would go out and it'd be fine. I'm told that's not how it works. So anyway, but the team is doing phenomenally well, and we work with a lot of different what we call PIs or principal investigators at NanoRacks, and you get all different kinds of things. You get folks that don't really understand what they want to do when they just have an idea. You get folks that maybe the worst are the ones that think they know exactly what they want to do, but and they're harder to teach. The team from Kesset Start University is doing phenomenally well. They're way ahead of where we would normally see a project at this stage, and I'm not just saying that, that's absolutely true. For example, on orbit, your experiment requires something we call Kermit, but it's the Kien's microscope. If a PI were flying one of those, they'd probably just come to us with the payload and we'd have to figure out if it's going to fit or not. You guys have one here. You've gone through the trouble of purchasing one and doing all your ground research and preparation in it, so we know it's going to fit. We know the fit checks are going to be perfect. We can test it all out. You have ground units ready to go. We were really impressed yesterday in talking to the team. Of course, there's going to be things that are going to be changed. Even if we build something and we go to NASA safety through that process, they're going to tell us to change things. That's just the way it works. But the team is doing great. I'll say this about the future, for example, of space research and space exploration in Thailand, and I'll use NanoRacks as an example. I believe the company started in 2009, right, Mike? So In 2009, in a garage in Houston, Texas, or Webster, Texas, NanoRacks started flying sort of an idea to fly mixed sticks or tiny little experiments. I will fast forward to today, which is 15 years later, and we're building a space station. So there's no reason that a country like Thailand, with quite frankly much smarter people than we had at NanoRacks over the course of this year, yeah, right, he's sitting right here, can't do that or more. There's no reason. It's just a commitment to go that route and sort of develop space as a sort of a platform for your future workforce development and sort of what you want to be later. As far as developing the workforce, I think this is a perfect example of how you do it. Get people involved in the education. When you're doing engineering work, for example, engineering is great. Engineering on space creates the opportunity and the desire to go work in that environment, in aerospace. Offering more courses, you don't have to, I know you have an aerospace department here, but offering courses specific to in-space research, for example, or in-space manufacturing, I think you'll find you'll develop a workforce that's going to leave the university and sort of create the market themselves in your country and in other countries in the region. We're seeing some other payloads from the region that are following along with, they're following the example that's being set here at this university. Companies like South Korea, the Philippines, et cetera, that we're starting to fly now. And we think that this region is going to become sort of a huge space, a huge platform for space development going forward. We really believe that. We've seen it in some of your neighbors like India and Australia, and we believe that the ASEAN region is going to just really expand over the next decade.
ก็สิ่งที่สกอตเขาเล่าให้ฟังนะคะเกี่ยวกับโอกาสเนาะที่ประเทศไทยจะมีส่วนร่วมในการที่ร่วมพัฒนาเกี่ยวกับเรื่องของวิทยาศาสตร์แล้วก็เรื่องของเทคโนโลยีสำหรับอวกาศซึ่งอาจารย์ณัฐพรก็เป็นหนึ่งในตัวอย่างที่ดีมากนะคะที่โชว์ให้เขาเห็นแล้วเขาก็ตื่นเต้นกับการได้มาเห็นงานวิจัยที่อาจารย์ทำนะคะซึ่งเขาก็มองว่าตอนนี้เนี่ยการพัฒนาเนี่ยไม่ได้ไกลเกินเอื้อมเนาะเขายกตัวอย่างของ NanoRack นะคะซึ่งก็เป็นบริษัทไม่แน่ใจจะเรียกสตาร์ทอัพถูกต้องไหมนะคะแต่ว่าก็คือเริ่มต้นในปี 2009 ซึ่ง 15 ปีต่อมาเนี่ยจากการเริ่มต้นพัฒนาสิ่งเล็กๆเนาะสำหรับการทำงานวิจัยในอวกาศเนี่ยมาไปเป็นการสร้างสถานีอวกาศที่กำลังจะถูกลอนช์ออกสู่อวกาศจริงๆในเชิงคอมเมอร์เชียลเนาะก็จะเห็นได้ว่าการพัฒนามันก้าวกระโดดมากเขาก็เลยบอกว่าประเทศไทยก็ไม่อยู่ไกลเกินเอื้อมก็อาจจะเริ่มต้นจากการพัฒนาทางการศึกษาเพื่อให้นักศึกษานักเรียนมีโอกาสได้เข้าถึงกิจกรรมงานวิจัยที่เกี่ยวกับอวกาศมากขึ้นนะคะตรงนี้ก็เป็นส่วนที่เราก็อาจจะมีโอกาสผลักดันตรงนี้ให้เกิดขึ้นมากขึ้นในประเทศไทยนะคะแต่อย่างน้อยก็มาทำงานวิจัยกับอาจารย์ณัฐพรได้ก่อนนะคะก็so I'll go back to you, Robert, on we have heard about like opportunity already, but then there's also what are the competency needed to tackle all the like complicated or complex problem that may occur in the space research. So if you have to mention about like what are the competency or the skills required for the future generation to join this kind of research.
That's a great question. I would echo what Scott said about how phenomenal the team here is doing and what it takes to develop a payload or a research experiment for a space station. There are so many different disciplines required that you have to have an understanding on. Electronics, structures, software, the underlying physics. There's so many disciplines, and there's room for everybody. You don't have to be a rocket scientist. You don't have to be a physicist. Everybody can play a part. There's so many different piece parts to an experiment. It's amazing, really, to see all the disciplines come together, and how much you learn not only about what you know and are doing, but you get to see how what your work does impacts a different discipline. If you're trying to select the computer that's going to help operate your experiment, how much power does that need? And Is it noisy electronically? These are things you have to consider. And not only about your payload and making it work, but how it's going to affect the payloads around you. The space station houses hundreds of experiments at any given time, as well as people. And so you have to make sure that your payload or your experiment is not only safe to operate, but is safe for the experiments around it and doesn't impact them, or it doesn't release materials or glass or something that might hurt an astronaut. So there's room for every discipline in one project, and the more you do, the more you learn about all the other disciplines, and the next thing you know, you're running a space station like these guys. So I could envision a day where the first astronaut from Thailand is looking through his liquid crystal display space helmet as he's installing a new sensor on the outside of the Star Lab to monitor the crop health of the fields here in Thailand. And I think that that day is rapidly approaching. There's probably a future astronaut sitting in this room. Who here wants to be an astronaut? Anybody?
เป็นนักบินอ
I
ว
know I
กาศ
do.
ยกมือขึ้นค่ะโหไม่กล้าเหรอไม่กล้าเหรอ
Come on
ไม่กล้าหน่อย
There we go.
Yeah. You don't? Okay.
It's
Yeah.
So that's a day that we could see in the next 5-10 years, and I think it's wonderful how much you've accomplished. I looked at the students and what they're working on, and I just think about all the opportunities they have that I didn't have when I was in school. And I'm listening to them talk, and I realize that these students are much smarter than I was when I was in school, and it's really exciting to see that the future generations are growing and learning much more than we ever knew. So.
Thank you. So สิ่งที่เขาพยายามจะบอกก็คือว่าการทำงานในอวกาศเนี่ยการที่จะต้องไปศึกษาทดลองนะคะมันก็มีความรู้หลากหลายสาขาเพราะฉะนั้นจริงๆสิ่งหนึ่งที่คิดว่าน่าจะเป็นองค์ประกอบสำคัญของคนที่จะมาร่วมงานกับการทำงานกับอวกาศคือการรู้รอบด้านนะคะเพราะว่าการทำงานจะเป็น multidisciplinary แล้วก็ safety concern เนาะการที่เราจะต้องรู้เรื่องของความปลอดภัยในการออกแบบระบบที่เอาไปใช้ทดสอบในอวกาศสิ่งที่เราทำนอกจากจะต้องดูเรื่องของความปลอดภัยที่เกิดขึ้นกับอุปกรณ์ของเราแล้วจะส่งผลกระทบต่องานวิจัยของคนอื่นไหมเลือกคอมพิวเตอร์เสียงดังไปหรือเปล่ามีคนอื่นทำการทดลองอยู่ในพื้นที่เดียวกันอันนี้ก็เป็นสิ่งที่ต้องระมัดระวังนะคะซึ่งก็ไม่แตกต่างกับการทำงานแลบที่เมืองไทยนะคะแลบข้างๆอาจจะมาบ่นเราได้ถ้าเราทำเสียงดังนะคะใช่ไหมคะก็อันนี้ก็เป็นสิ่งที่เขาอยากจะฝากทีนี้ so I'll back to you Mike on we have learned already about like some competency needed like multidisciplinary and safety concern are quite important to exploration in the space and how about the future job that would be associated with the space economy maybe they're picking their career at the moment they're picking their area of study at the moment could you inspire them what are the opportunity out there
No pressure.
At all?
No pressure, just inspire everybody in the room. Great.
We need to inspire some more astronauts.
Yes,
and maybe their parents can hear like what's not existing now, but maybe in the near future.
So we showed you a video of the next generation of spaceships, right? Now, humans love to explore. And if we're going to go further than we have right now, we're going to put spaceships around the moon, we're going to go to Mars, we're going to go beyond. And to do that, we need more than just aerospace engineers. We need everybody. We need people that can grow plants. We need people that can do molecular biology. We need people that understand ergonomics and the science of being able to live in a space. You saw that one of our partners was Hilton Hotels. And the reason is, for one, like, people need to be comfortable, and they're experts in that. And people need to have antimicrobial cloths, and they're experts in that. So we need everybody. Space isn't just for rocket science. It's not just for engineers. It's for everybody in this world.
ก็อันนี้ก็พยายามจะชี้ให้เห็นนะคะว่าโอกาสในอนาคตอาชีพในอนาคตที่จะมาเกี่ยวกับการวิจัยในอวกาศคืออะไรแล้วก็โดยเฉพาะยิ่งเนี่ยถ้าเราพูดถึงเรื่องของการสร้างเศรษฐกิจใหม่ในโลกอวกาศนะคะก็อาจจะเห็นได้ว่าทำไมนาโนไลท์ถึงเลือกไปพาร์ทเนอร์กับฮิวตันเนาะเขาก็บอกว่าจริงๆแล้วนอกเหนือจากจะมีคนที่เป็นวิศวกรเป็นนักวิทยาศาสตร์ที่ทำงานด้านงานวิจัยเกี่ยวกับอวกาศแล้วเนี่ยก็ยังมีอาชีพอื่นๆนะคะเรื่องของการดูแลสุขภาพนะคะดูแลต้นไม้นะคะการปลูกพืชในอวกาศนะคะการดูแลเรื่องของสุขลักษณะต่างๆนะคะความปลอดภัยนะคะอันนี้ก็เป็นเรื่องสำคัญเพราะฉะนั้นจริงๆแล้วเขามองว่าโอกาสเนี่ยไม่จำกัดเลยเพียงแต่ว่าเรามองเห็นโอกาสนั้นหรือเปล่านะคะในการที่จะสร้างสิ่งใหม่ๆนะคะโดยที่อย่างยิ่งเราเห็นว่าการเปิดกว้างเรื่องของการที่จะพัฒนาเศรษฐกิจบนอวกาศมากขึ้นเนี่ยเราก็อาจจะต้องใช้จินตนาการนิดนึงนะคะแต่อย่างน้อยเนี่ยพื้นฐานสำคัญก็คือความรู้ของเข้าใจพื้นฐานที่บนโลกนี่แหละแต่ว่าเมื่อบริบทเปลี่ยนไปเนี่ยเราจะประยุกต์ใช้ความรู้ของเราเนี่ยกับโจทย์และความท้าทายใหม่ๆได้ยังไงนะคะทีนี้ก็อยากจะมาถามทางอาจารย์ณัฐพรค่ะ so I'd like to ask อาจารย์ณัฐพร about maybe we learned about the opportunity already but always success come with some like key driver right so I'd like to learn a little bit about like as a researcher what is the things you consider key driver of success in the space science especially in research
so for the work that we do as an example so the key success is you are good observer so the question they're going to ask you is for example when I defend the project when back with the BPS the Biological and Physical Science Division at NASA, they asked me very harshly, why do you want to go to space? Well, tell me. And then I was like, whoa. But I prepare. So I said, okay, in space, there's no gravity and there's convection. And I want to test the heat gradient that would affect liquid crystal. Because when your display is the pixel die and so on, it causes from fluctuation of the temperature, for example. So this is one of an example that you will have to be firm with what you observe and what you want to test. Why do you want to go to space? So it was lucky that I work in the fluid. Liquid crystal is fluid. And that's the main thing that they are quite interested in space because it doesn't take shape. So when you open the bottle of water, it go anywhere. So it's quite difficult to control. That's why they study a big thing about fluid, about colloid, like something suspended in water. So one thing as the researcher to go to space, you have to be a good observer. You have to be a good scientist so you can do your hypothesis and defend why do you need microgravity. Okay, so that's one thing. And the second thing is you need to be patient. Patience is the key to the big project. Because for me, I take 2 years of writing an MOU. They go with me every sentence. That's not even the starting of the project. So that's 2019 when I learned that, okay, so you work with the program scientists at BPS at NASA, and they meet me almost every 2 weeks. Okay, go with this paragraph. And it's end up the MOU is 15 pages, and it takes me 2 years to work with him to finally get the MOU. And then that's the first patience. When you get that patience, now the next one comes, you have to find the money. It's not 100,000 baht. It's order 100 million baht. So you will have to work with, well, first thing, I have a very good boss. I have a good dean here. He's a big supporter of our project. We have a great president. So the dean bring me, okay, we go meet the president. You be prepared. And then I'm nervous, but I'm ready. So we go present to the president. And he said, you go with the project. The university is funded. So we get the initial money. And then we go more because we need 100. So we go to the funding agency. We have our partner, which is JISDA, the Space Agency of Thailand. Because you do the space project, you cannot go on your own. So you need partner. So we tag along with JISDA. We go asking for funding from the government of Thailand. And we here to this point, we got over like 60, that's the funding agency alone, 60 million, and it's more to come. So we have, this is take me like 2019 to 21, get MOU, 21, 22, 23, get funding. 24 right here got more funding. So it takes me about 2 to 3 years to get funding from the government. And now another patients come because you have to build the equipment. And you have to get up 7 a.m. You have to stay up late until midnight to work with nanoracks.
No complaint here. No complaint here.
It's not a complaint. It's a thank you note. Yes. So our team is like a big patience to all of my team, the student, the professor, and also the postdoc. So patience is the second key. And the third key is diplomatic. You have to work with a lot of people. You have to talk to several partners. And also like the hardest one might be when you have to deal with the NASA. So that's, I bring my president, I bring the dean to NASA headquarters to talk to them, to discuss. Because like the project will, like my advisor, he take 15 years. He told me to go to space, you'll feel a few obstacles. So he was like warning, it's a warning. So he was like, you have to face, like you have money, you have no money, you have money, no money. We feel that, okay? We make it because we have good support from our school, from the president, from the dean. So because we all are like, have a good communication skill as well. So you have to be friend with people. You have to make sure that they like us, so we can keep going. So communication skill is another thing. Being diplomatic is another main thing that if you want a success in your big project or in business, you have to have that. This should be another thing. So I have 3 things. Patience. Yep. What's the second one?
I got like almost 6 now, so anyway.
Money. The third one is diplomatic. Okay, all right.
ก็สิ่งที่อาจารย์ณัฐพรอยากจะฝากค่ะเรื่องว่าทำยังไงให้ประสบความสำเร็จกับการทำงานวิจัยโดยเฉพาะการทำงานกับหน่วยงานระดับโลกเนาะสิ่งที่อาจารย์บอกอย่างแรกก็คือความช่างสังเกตความเป็นนักวิทยาศาสตร์นะคะก็ต้องมีความช่างสังเกตนะคะมีความอดทนนะคะสิ่งที่อาจารย์ได้มาวันนี้ซึ่งมีนักวิจัยจากนาซามาเยี่ยมเรามาไซน์ MOU ร่วมกับเราเนี่ยอาจารย์ใช้เวลาหลายปีมากในการเริ่มพูดคุยเจรจานะคะจนถึงวันนี้นอกจากนั้นการทำงานใหญ่ก็ใช้เงินเยอะนะคะอาจารย์ก็เลยบอกว่าสิ่งที่3ที่เป็นเรื่องสำคัญก็คือเรื่องของกำลังทรัพย์เนาะซึ่งอันนี้มาพร้อมกับการซัพพอร์ตจากหน่วยงานอื่นๆดังนั้นเนี่ยการหาพันธมิตรในการทำงานหรือว่าพาร์ทเนอร์ชิพเนี่ยก็เป็นเรื่องสำคัญนะคะซึ่งการที่จะได้มาซึ่งพาร์ทเนอร์ชิพเนี่ยก็จะเป็นอย่างยิ่งที่จะต้องมีความสามารถในการสื่อสารที่มีประสิทธิภาพเรื่อง communication skill แล้วก็ negotiation skill นะคะซึ่งอันนี้อาจารย์ก็บอกว่ามันก็แฝงมาด้วยความเป็น diplomat นิดๆเนาะนักการทูตหน่อยๆนะคะว่าเราจะต้องเจรจายังไงเพื่อให้สามารถได้รับความร่วมมือนะคะอันนี้ก็ฝากน้องๆไว้ว่าอันนี้นอกจากเราจะเรียนวิทยาศาสตร์เก่งแล้วเนี่ยทักษะรอบด้าน soft skill ต่างๆเนี่ยก็เป็นเรื่องสำคัญนะคะที่เราจำเป็นจะต้องทำงานกับผู้คนมากมายแล้วก็หลากหลายวัฒนธรรมอันนี้ก็เป็นเรื่องที่เราสามารถฝึกฝนได้นะคะแล้วอาจารย์ณัฐพรก็เป็นตัวอย่างที่ดีที่อาจารย์สามารถเริ่มต้นงานวิจัยจากในประเทศไทยแต่สามารถเชื่อมความสัมพันธ์ไประหว่างประเทศได้นะคะทีนี้เรามีวิดีโออีก1 อันค่ะเรามี special guest so we have special guest today so we have a little bit of the video showing her exciting work and we might ask her a little bit about the project there was or there is.
I can tell you one thing I'm going to do when I get back to Houston is find out why our teams don't think they can meet until 10 p.m. your time. That's 10 a.m. We're about 12 hours behind you guys.
America has always had a frontier. Now that frontier is upward and it's out into the cosmos. And we will continue to push the boundaries of space exploration.
It's been a very collaborative effort across multiple NASA centers with our industry partners. This team, we've done a tremendous amount of work getting ready from designing, manufacturing, and testing the spacecraft to ensure its success as we embark on our first mission to the moon.
And for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
To all personnel, OTC, GTC, MC.
Go, control, go, GNC, go, stop, go, CD, go, pilot, go, FAO, go, FBM, go, alright, go for launch.
And here we go. 3, 2, 1. Boosters ignition. And liftoff of Artemis 1. We rise together, back to the moon and beyond.
Copy that,
Confirmation that the solid rocket boosters have separated.
Controllers are there to make sure that the burn goes off well and just in general we got where it's supposed to go. Flight control, ICF is managing control and maneuvering soon.
This view of Earth captured from a human-rated spacecraft not seen since 1972.
We'll dip in for a 60 nautical mile flyby of the lunar surface using the engines on the European service module to push us around and into DRO. We're going to be about 38,000 miles away from the lunar surface. We're going beyond anywhere we ever went for Apollo. Spacecraft is barreling its way back home after circumnavigating the moon and beyond. Drogues have been deployed. Good main chutes for Orion. Splashdown. Orion, back on Earth. This is what mission success looks like, folks.
เราก็ได้ดูวิดีโอเกี่ยวกับ Artemis นะคะทีนี้ก็มีนักวิจัยที่ทำงานกับ Artemis นะคะ so now I'd like to give a little bit of stage time to Verniel. They have been working on the Artemis project and we'd love to learn a little bit about your role in NASA and what is so excited about Artemis 2.
Oh, absolutely. Good morning. So I am part of the Artemis program, which is the return to the moon. So NASA does some phenomenal things, one of them being science, and I rely on all that science and technology development so that we can go beyond. I worked on the space station program for many years and helped contribute to that, and now I want to go beyond. So what you just saw was our Artemis 1 launch. So this was our first launch. It was uncrewed of the Artemis missions. So I work on the spacecraft specifically, so I'm responsible for the end-to-end, both production, testing, and mission execution for the Artemis 2, which is going to be our first crewed mission, which is next year.
Wow, so excited. So now like we have learned a little bit about like all the exciting things happening in space and also back on Earth. So now I'd like to give some space and like the time for the questions from the audience because you have been so patient listening to us for hours. Right? Seems like forever. So now I think it's time for giving a couple like questions from the floor and feel free to ask in Thai. ก็อยากได้คำถามค่ะจากน้องๆว่ามีคำถามอะไรอยากจะถามทางอาจารย์นักวิจัยหรือว่าพี่ๆที่มาจาก NASA นะคะว่าอยากรู้เรื่องอะไรบ้างนะคะถามเป็นภาษาไทยก็ได้ภาษาอังกฤษก็ได้นะคะ
Got one up there. Oh, he's got it. He's got it.
ขออนุญาตไปหนึ่งนะครับ
น้องเสื้อชมพูนะคะ
โอเคครับขออนุญาตไปหนึ่งอันนี้ผมขอให้ข้อเสนอแนะได้ไหมครับข้อเสนอแนะครับแต่ว่าไม่ได้ถามคำถามครับแต่ทีนี้ว่าไอ้โครงการนาซาครับเองผมคิดว่าครับในอนาคตเนี่ยอาจจะเป็นไปได้เปล่าว่าหากมันนะครับว่าหากเราจะเอานำความรู้ที่เกี่ยวข้องกับอวกาศอะไรเงี้ยไปใช้ในการพัฒนาเกี่ยวกับสัญญาณอินเทอร์เน็ตเหล่านี้ครับจริงโดยใช้หลักของคณิตศาสตร์เหล่านี้ครับจริงมันจะไปได้เปล่านะครับในอนาคตผมอยากจะให้ทางนาซาเนี่ยเปิดโอกาสให้นักคณิตศาสตร์อะไรเงี้ยให้ไปพัฒนาเกี่ยวกับทางด้านเลยนะอัลกอริทึมอะไรเงี้ยซึ่งมันจะมีผลต่อเหมือนกับว่าอวกาศอะไรเงี้ยปล่อยสัญญาณขึ้นอินเทอร์เน็ตไวไฟหรือไม่ระบบคลาวด์เหล่านี้ครับจริงเพราะว่าปัจจุบันเหล่านี้เนี่ยข้อมูลข่าวสารเหล่านี้เนี่ยมันจะไหลช้ามากเลยครับจริงเพราะไม่ได้จะมีระบบซัพพลายเชนเนี่ยปริมาณจำนวนมากทำให้การทำงานมันยากขึ้นเรื่อยๆครับ
ขอบคุณมากค่ะ So it's more like a comment that it might be an opportunity for the mathematicians to involve in like some development during for the communication systems, especially applying back to Earth, like how to help advance internet communication back on Earth.
So first of all, I'm very disappointed that math is extremely important in space because I'm terrible at it. But I will say, comms or space-to-ground communications is a big issue right now with deep space exploration and even with low Earth orbit. We cannot download as much data as fast as we would like, even from the International Space Station. It's something that we're looking at. NanoRax is going to be putting a laser communication system on our airlock on Space Station and testing it out for space-to-ground communications and even space-to-space communications. But comms is a big issue that we don't have a good solution to yet. There are workarounds, there are okay solutions, but if somebody can develop a really good comm system for moon to Earth or deep space, back space to space, that's going to be a big step forward in technology.
Thank you so much. ก็สำหรับคอมเมนต์แล้วกันนะคะว่าจะมีโอกาสสำหรับนักคณิตศาสตร์สำหรับการทำงานเรื่องการพัฒนาระบบสื่อสารหรือเปล่าจริงๆเขาบอกว่าเขาเนี่ยจริงๆแล้วเรื่องของคณิตศาสตร์เนี่ยเป็นเรื่องสำคัญมากนะคะเรื่องของการคำนวณเนี่ยซึ่งเขาไม่ค่อยเก่งเขาเสียใจนิดหน่อยนะคะแต่ว่าจริงๆแล้วเนี่ยปัญหาที่เกิดขึ้นในปัจจุบันก็คือเรื่องของการติดต่อสื่อสารระหว่างดวงจันทร์กลับมาที่โลกก็ยังเป็นเรื่องยากการดาวน์โหลดข้อมูลต่างๆก็ยังเป็นเรื่องยากเพราะฉะนั้นเนี่ยยังเป็นแกปใหญ่เลยนะคะที่ต้องการงานวิจัยนะคะพัฒนาการระบบสื่อสารที่ดีขึ้นไม่ว่าจะเป็นการที่ตอนนี้เราเริ่มจะสนใจ Mission to Mars ไปมากกว่าแค่ดวงจันทร์แต่ไปแค่ดวงจันทร์ก็ยังมีปัญหาเรื่องระบบสื่อสารเลยดังนั้นเนี่ยการพัฒนาระบบสื่อสารเรื่องสำคัญมากนะคะตอนนี้ยังทำได้ไม่ดีนักนะคะมีเรื่องของการใช้เลเซอร์เทคโนโลยีแต่ก็ยังมีโอกาสสำหรับเทคโนโลยีอื่นๆอีกนะคะก็หวังว่าจะเห็นน้องๆมามีส่วนร่วมในการพัฒนาระบบสื่อสารอวกาศนะคะก็เชิญท่านต่อไปเลยค่ะ
ครับผมชื่อแฮมนะครับมาจากโรงเรียนจุฬาภรณ์ปทุมครับสำหรับความสนใจผมนะผมสนใจเกี่ยวกับเรื่องเทคโนโลยีภาพถ่ายดาวเทียมครับแต่ว่าวันนี้ก็แอบได้ยินเรื่องเกี่ยวกับธุรกิจเศรษฐกิจอวกาศก็เลยเกิดข้อสงสัยเหมือนกันว่าในประเทศไทยเราครับเรามีธุรกิจของภาคเอกชนที่ทำงานเกี่ยวกับด้านนี้แล้วหรือยังแล้วก็มีหน่วยงานไหนครับที่แบบว่าสามารถรองรับเกี่ยวกับพวกมาตรฐานต่างๆได้แล้วก็ในอนาคตนะครับในฐานะที่ประเทศไทยเราเป็นประเทศที่กำลังพัฒนาครับผมสงสัยว่าเราจะมีแนวโน้มในการเติบโตของธุรกิจเกี่ยวกับเรื่องอ อวกาศทั้งแบบเรื่องอาหารบ้างหรือว่าเทคโนโลยีบ้างมากน้อยแค่ไหนครับ
So I'll do a little bit briefing, but then now I think I address this to Janatapon. So Ham is high school students from Julapon school, and his interest is toward space imaging. But after hearing all about like your fascinating work, he's curious about the space economy and how Thailand would involve in the space economy. Would there be any organization that associate to that, and would there be any standardizations organization that involve?
Okay, so I'll answer in English then. So the organization that involved for testing the space safety, we have here in Thailand at GISTA. I'm not sure if you are familiar with the name, Geoinformatics and Space Technology Agency of Thailand. So they're situated in Sriracha. They have all the testing for the satellite. So what you need to test for satellite, like vibration test, thermal cycling test, and electromagnetic test. So over there they have facility that you could, I mean, if in the future, if you're doing space industry, you could use it. This is from the government of Thailand. So my payload that I'm developing, we also use the facility over there, which is the same one that used for testing TOS-2, the satellite that went to space last year. So that's what the country have available. And for the technology that related, industry that related to space, we also have it in Thailand. You probably would hear about the startup company, for example, Mu Space. They start developing the satellite. There's another company, for example, Lumentum. They're building the laser system, an optical system for SpaceX. So the production base is in Thailand. So I would like to advertise here as well that on Friday, the 17th, we have another seminar forum. We invited the local Thai that related to the space industry to join us in the seminar at the Westin Grand in the afternoon. So wait to hear from us. You will hear from the Kasetsat University website. We have registration that you could register and join us for free. So then we have another business is simulation, which everyone can participate. So our lab, we use the software called ANSYS, which is the engineering software for finite element. High school student, you can train for that. So this software is quite expensive. NASA also use it a lot. NanoRacks use it a lot. So we were sponsored. We also was sponsored by the company called CatFem. So we use it a lot too. All of my students were trained for that. We have a student like undergraduate that come for a short term. They're being trained for that as well. So if you're a high school student and you are energetic to join the space, you can join us for initially like the start is like doing the simulation for space. So we have all the facility that could do that, and we have the training. The company train our student. So we have, as I said, CatFem is our sponsor. So they bring the team and train the whole group of the student to be familiar with all this software to simulate what would be like in space for your equipment. So this is an example. Yes.
ก็จริงๆแล้วประเทศไทยก็เริ่มมีสตาร์ทอัพนะคะที่ทำงานเกี่ยวกับเรื่องอวกาศเดี๋ยวอาจารย์ณัฐพรก็แอบขายของไปแล้วค่ะว่าจะมีเซมินาอีกครั้งหนึ่งนะคะก็วันที่17ก็ยังไงก็รอติดตามกันนะคะส่วนเรื่องของการที่จะทำงานเข้าไปเกี่ยวข้องเนี่ยมีตั้งแต่เริ่มต้นนะที่ใครๆก็อาจจะเข้าถึงได้ก็คือเรื่องของการทำซิมูเลชันซึ่งก็จำเป็นต้องเก่งเรื่องคณิตศาสตร์อีกแล้วใช่ไหมคะแล้วก็เป็นการจำลองสิ่งที่เกิดขึ้นนะคะว่าจะมีการเปลี่ยนแปลงยังไงเมื่อเกิดปัจจัยกระทบภายนอกไม่ว่าจะเป็นทางกลทางความร้อนต่างๆจะกระทบกับโครงสร้างยังไงนะคะแล้วก็อีกเรื่องหนึ่งก็คือเรื่องของการที่มีหน่วยงานวิเคราะห์ทดสอบความปลอดภัยอวกาศอยู่ที่จิสตานะคะที่ศรีราชาซึ่งอาจารย์ก็มีโอกาสได้พัฒนางานของอาจารย์ไปทำงานร่วมกับจิสตานอกจากนี้ก็ยังมีเรื่องของการทดสอบการปล่อยต ตัวของดาวเทียมนะคะซึ่งอันเนี้ยเมืองไทยก็มีการพัฒนาดาวเทียมขึ้นเองนะคะทีนี้ I think we kind of running out of time, so maybe I wrapped now. So I'd like to give you a few minutes to give a final remark, each of you. Maybe starting with you, Scott.
There we go. I just want to say thank you again. It's been a real pleasure being here. We've met a few of the members of the team in the United States on a couple of different occasions for the TLC project, but getting to come over here and meet the rest of the team and work with everybody for even a brief period of time at the university has been wonderful. I'm really excited to fly this. I'm really excited to bring it back when we return it from the ISS. I hope we are invited back and we can come present the hardware in person and you know, hear about the results and what the team's learned. And I'll also say that I'm going to go home and talk to our team and find out why they think they can't meet with you until 10 a.m. in the morning, our time. I think we can find an earlier time. But thank you very much. Thank you.
I'd just like to say it was so wonderful of Natapurn to invite us out here to meet with everybody. Been so impressed with the work the students here are doing. You've done a great job with the team. They're so far ahead. I hope it's the start of many more research projects to come, and hopefully we'll be flying a lot of Thailand research on the Star Lab when it gets to space. And I hope we can support that as well. So, you know, really looking forward to seeing the results of this project, and looking forward to more yellow curry. So.
Can I say that normally when Robbie calls us about payloads, it's what's going on with these guys? What is the problem? Can you not get them in line? And we're not kidding. The team is doing phenomenally well. We're not having to do anything. We're not getting any. If I don't hear from him on this, I know it's going really well. And we're not hearing from him on this.
Yeah. Guys, thank you very much for having us. We're very impressed, obviously, with Kansas Art University, your department chair, president, thank you, and to the people in your lab, thank you. Space is not easy. In fact, space is very hard, and it takes a lot of people to be able to make something successful in space. And we're very happy that we're part of that team. We're happy that your team is so far so very successful, and we're very excited for everybody in this room to think about space as a career opportunity, and as we build the space program in Thailand, that you guys are a part of it. Thank you.
Well, thank you very, very much for just giving me an opportunity to talk with folks today. One of the most inspiring things that I do all the time is actually to talk to students, because you remind me of how amazing it can be, and I truly do love that. I think you missed two things, though, when you talked about your three items. I think one of them's perseverance. I think you have shown that perseverance quite a bit. But the final one is a key one, and you have it, and it's passion. And it's passion that will drive all of the above. And so I hope that that passion has shared today, because it's my passion to go to the moon. It's my passion to go beyond, and utilizing the science and the research that your incredibly talented students and professors here have done is what's going to drive that. So thank you very much for all that.
Thank you. That's easier. Yes, thank you. So I thank you all, the audience, the students that come here. We're here to inspire you all. Like, the space is difficult. Space is far away. Space wouldn't take only just one person to achieve the project. So you have to put together the team. You have to, as I said, be patient with big passion. So they're here today that as a guest to Thailand Liquid Crystal in Space, and I really appreciate their presence here, because that drives me to get even more passion to bring, when he said about the Star Lab, I was like, oh, already start imagination. That's the next thing to come. So, but next year, well, as a promise from my team and me, together with the support, ISS National Lab, NanoRacks, powered by Voyager Space, NASA team, will go to space. We'll bring the first Thai payload to space. So all the students, I'd like to hear the clap from you. Thank you. Thank you.
Thank you very much, all the inspiring speakers, to give us like some excitement about the bright future of Thai researcher and also collaboration with NASA. And hopefully one day I'll see some of you on this stage talking about your experience working with NASA or others, like international experience that you have, and inspire other generation. Thank you very much. And give big round of applause to everyone here. Thank you so much. ขอบคุณมากค่ะ